Alright, hi everyone. Today we're looking at conditional probability. I'm just going to explain it using a bit of an example. Suppose someone came up to you and they said, here are a pack of cards, but I've only got an ace. I've got an ace, so my sample space here that I've got is an ace, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. They're all the cards I've got in my hand. I've only got 1, 2, 3, 4, 5, 6, 7, 8 of them. Pick a card. And so you pick a card, and the person goes, "Oh, what's the probability that it is even?" Let's actually call an ace a 1 for now. Okay, let's just say that it's 1 to 8. And you say, okay, let's make event A the card is even. Okay, it's an even numbered card, so it's a 2, 4, a 6, or an 8. What's the probability of that, says the person. And you're pretty clever, so you say, oh, well, the probability is obviously, there's 1, 2, 3, 4 choices that are even out of 8, so that's going to have to be 4 over 8. So probability of event A even is 4 over 8, which is, of course, a half. And so this person goes, so it's probability is a half. Okay, interesting. What if I told you that the card I have picked out is less than the number 4? It's less than 4. They say, what if it's less than 4? So B is less than 4. Less than a 4. So it's either a 1, a 2, or a 3. It says, what's the probability now? Now that I've told you that it's less than 4, what is the probability that it's even? And you go, I already know that it's less than 4, so I know it's a 1, 2, or 3, and you're asking me if it's even or not. Well, now there's only one chance in 3. So I can say, well, now I know that the probability is a 1 in 3 chance now. So you started with something that the probability of it being even was a half, but then given that you knew something else, given that you knew it was less than 4, that probability is a little bit different now. It's now a third. And that's what we mean by conditional probability. It means the probability of something given that you know some more information. And here's how we write it. We write the probability of event A given that we know event B has already happened. Event A given event B is 1/3. Okay, and there's a bit of a formula that goes along that allows you. Obviously, here we just did it through intuition. We figured it out, but there's a bit of a formula that will allow you to figure it out every time, especially when the example's complicated and you can't use intuition for it. And here's what it is. It says the probability of A, given that B has already happened, is the probability that A and B will occur, divided by the probability that event B will occur, the thing that's already happened. So let's take a look at that formula using our example here. So the probability that A and B happens, that's the probability that it's going to be even and less than 4. So even and less than 4, there's only 1 out of 8. So that's up the top, so 1 over 8. Divided by the probability of B. That's the probability that we have something less than 4. So there's 1, 2, 3 out of 8 for that. 1/8 divided by 3 over 8. Now using our knowledge of dividing fractions, 8 comes down, and this 8 goes up. So that's on the top we've got a 1, and this 8 goes up, so we've got a 1 times 8. On the bottom we've got a 3, and the 8 goes down. The 8's cancel out, leaving us with 1/3, which is good because that's what we had using intuition as well. So that's basically all there is to it. Perhaps I shall give you another example as well. Okay. All right. Let's say there's. So let's do another example. Example 2. Okay. Let's say that there is a class, or a bunch of students, and all of them do. Well, let's say in total there are 30 students that we're talking about here. Students. And we know that all of them either do music or music, or perhaps they do drama. Okay, they're a bunch of arty students. Perhaps none of you are these students, but anyway. And we're told that there are 22 students doing music, and there are 15 of those students doing drama, and all of the students do at least music or drama, and some of them do both. So let's think about this a bit clearly to see who does both. Okay, so let's set this up in a bit of a, let's use a Venn diagram to figure out who does both. Okay, so here we've got music, here we've got drama. Music, drama. Alright, so let's have a look. There's 30 students in total, so there's no one out not doing anything. Okay, so when we add all three of these together, we're going to be getting 30. So when we add music plus drama, take away one of, this is the addition law by the way, take away one of the musics and dramas, we get 30. So let's write this down. We've got 22 musics plus 15 dramas, take away this, equals 30. So we've got 37 here. Take away whatever this is, equals 30. So the intersection bit here must be 7. So this center bit is 7. That is 7. Which means in drama we need 7 plus something gives 15, so it must be 8. And for music, something plus 7 equals 22, so it must be 15. There we go, there's our Venn diagram. Now, suppose we select a student, from those 30 students, we select a total random student. So we're selecting a random student, and we want to know the probability that we ask that student, do you do drama? And they say, yes, I do drama. And we want to know what is the probability that they do music, given that we already know they do drama. Okay, so that's going to be the probability that they do music and drama. So we're using the formula here, divided by the probability that they do drama. Okay, so that's using our conditional probability formula here. So probability of music, given that they do drama, is the probability that they do music and drama, divided by the probability that they do drama. So let's fill in the information that we know. The probability that they do music and or drama, well, that's 7 here in the middle. So that's a 7. Oh, whoops, I haven't calculated probabilities, have I? Whoops. Okay, this is all in terms of people at the moment, so I need to calculate probabilities for all these things. So 15 over 30, this one here is obviously a half, because 15 over 30. 7, that is 7 over 30. And 8, that is 8 over 30, which is 4 over 15. Oops, my apologies. So 7 over 30 divided by probability that they do drama. Well, that's 7 plus 8. So that's 7 plus 8 is 15. So 15 over 30 gives 1/2. So 7 stays at the top. This 2 jumps up. 1 stays at the bottom. 30 drops down. 14 on 30, which is the same as 7 on 15. So there we go, that's the probability that they do music given that they already do drama. So there we go, that's essentially conditional probability. It's just using that formula that you'll need to write down and be very good at using this formula here for the conditional probability. Okay, that's basically all you need to know, but I want to show you how we actually got that result at all. So for the next bit of the video, I'm going to show you how it was that we figured out this formula, and I'm going to remind you of something that we've looked at in the past, which was the tree diagrams. So let's check out a tree diagram. Here we go. Remember this example from a few videos back where we picked a marble out of a bag and we didn't put it back, and then we picked a second marble. We started off with there being 4 reds and 2 blues was what we started off with in our bag. And I might just I'm going to write this example again on a fresh place so that we can do this a bit more easily. Where am I? Okay, so let me write this one down again. So we're picking a marble out of a bag, not putting it back, and then picking a second one out. So we start off with 4 reds and 2 blues. So on our first pick, we could get a red or a blue. And getting a red, that's 4 out of 6, or 2/3, and blue must therefore be 1/3. On our second pick, we could get a red or a blue. So we could get a red or a blue. So we could either get red, red, or we could get red, blue, or we could get blue, red, or blue, blue. So if we pick a red first up though, one of our reds has disappeared. So then getting a red will be 3 out of 5. And getting a blue will therefore be 2 out of 5. Now if we had actually picked a blue first, we'd have 4 out of 5 reds. So that'd be a 4 out of 5. And getting a blue would be a 1 out of 5. Okay, now let's think about what these probabilities are that we've just written down. This one here is the probability of a red on our first pick. So I'm going to say R1 for first pick red. And this one is the probability of not, let's say, of the complement of R1. Okay, it's getting blue. Complement of R1 is getting a blue on our first pick. So this one means first pick. This one means just means complement. Okay, actually all right. This one here is saying this is the probability that we get a red on our second pick, given that we've already got a red on our first pick. This one here is the probability that we get that we don't get red on our second pick, given that we got red on our first pick. This one here is the probability of getting red on our second pick, given that we didn't get red on our first pick. And this one is the probability of not getting red on our second pick, given that we didn't get red on our first pick. Okay. Now we also have overall this full thing. If we do, that's 1/5. That's 4 there. This is that, and that's the 3. There we go. Now, if we get a red and then a red, probability. So getting a probability of red is actually 2/3 times 3/5, which is 6/15. Now, a better way of writing this than just probability red is actually the probability that we get a red on our first pick and a red on our second pick. So the probability of getting a red on our first pick and red on our second pick. This one here is the probability of getting red on our first pick and not red on our second. This one here is blue-red. Blue-red is probability of getting not red on our first and red on our second. And this one down here is the probability of getting not red on our first and not red on our second. So there we go. Here are all our probabilities. Now, just like this one, to find the probability of red one and a red on the second, we did this probability times that probability. We did here the probability, this probability here is this, probability of getting red on our first pick. So we did that, probability of red on our first pick. Oops, I should write probability of red on our first pick. And we multiplied it by this here, which is our probability of red on our second pick, given that we got red on our first pick. Okay, so check out this line. Okay, check out that line. I'm going to write it down below just to make things a little bit more clear, I think. So we've got probability of red on our first and red on our second is equal to probability of red on our first times the probability of red on our second, given that we got red on our first. Okay, now this probably looks confusing, but it's probably my fault for choosing these bad events where I said that R1 equals red on the first pick, red first pick, and I said that R2 is red second pick. So I'm going to, at this point, just to make it a little easier to understand, I'm just going to call this A instead of R1, and I'm going to call this one B instead of R2. Actually, other way around. I'll call the first pick B, and the second pick I'll call A. Okay, and you'll see why in a sec. So I'm changing them around. R1 I've now called B. I've just changed the letter. There's nothing I've changed. I've just changed it to make it look nicer. R2 I've called A now. So R1 is B. Probability A given B. Okay. Now check this out. Instead of multiplying by B, I'm going to divide both sides by that. So I'm going to put that under here. Okay, so let's see what that looks like, and I'll write this one on the left hand side. So we've got probability of A given B equals, so that's that bit, equals this bit divided by that bit. Probability of B B and A over probability B. And that is exactly our conditional probability formula. Conditional probability formula. So we've actually been using this conditional probability formula thing all along, but without knowing that we were using it, without knowing that we were. And it's just the exact same thing as these tree diagram questions, where here this looks a bit more complicated than it really is. So it's actually pretty simple. Just follow the formula and you can't go wrong. Alright, get some practice in and you'll be an expert in no time. See you later.